A voltage amplifier receives a signal level of 20 microvolts, amplifies it, and delivers a swing of 50 millivolts to the load circuit. Calculate the voltage gain in decibels. Here, input is 20 microvolt, whereas the output is 50 millivolt. Voltage gain is the ratio of output voltage to input voltage. In other words, it indicates the factor with which input voltage is multiplied and presented at the output. Voltage gain in decibels is 20 log of V out by V in to the base 10. In this question, 50 millivolts is V out and 20 microvolts is V in. When you solve, you get around 68 dB. For voltage and current gains, the ratio is output voltage by input voltage, output current by input current. Power gain means output power by input power. They all follow the same notion. But when coming to decibel gains, decibel voltage gain is 20 log of V2 by V1 to the base 10. Here V2 subscript 2 indicates output port and subscript 1 indicates input port, input parameter. dB in current gain is 20 log of I2 by I1 to the base 10. But the important factor is dB power gain is 10 log P2 by V1. It is not 20 log P2 by P1. So why this is so? If you see power, it is product of voltage and current, or you can also write as V square by R or I square into R. If you consider normalized resistance of 1 ohms, then power is nothing but V square or I square. So you can replace P2 by V2 square and P1 by V1 square, or you can replace P2 by I2 square and P1 by I1 square, considering normalized resistance R is equal to 1 ohms. In that case, you are going to get 10 log of I2 square by I1 square to the base 10, which is going to become 20 log of I2 by I1 to the base 10. Voltage and current are the basic circuit signals, whereas power is the multiplication of the two basic circuit signals, voltage and current. The product of voltage and current is the power, and hence if you see the order of magnitude, it is product of voltage and current. Here we are going to have 10, not 20.